So in the previous video, we looked at calculating the absolute uncertainty of measurements, the absolute uncertainty of the mass, of the angle, of the height, of the displacement, the range, and we didn't calculate the absolute uncertainty of the time, but you could. This time in this video, we're going to calculate the absolute uncertainty when we're using a formula. Now, if you're measuring things, and let's say we measure the perimeter of a rectangle, we have an absolute uncertainty on that length, and we have an absolute uncertainty on that length, and an absolute on that length, and an absolute on that length. And the total absolute uncertainty of the perimeter would be the absolute uncertainty of one length plus the absolute uncertainty of the other length plus the absolute uncertainty of the other length of the width plus the absolute uncertainty of the width. And that's easy. We can just add all those together and it'll give us a total absolute uncertainty. However, when we are doing a formula like this one above here, mgh, where the potential energy is equal to mgh, we're not adding these values together anymore, we're actually multiplying. And when we multiply, it becomes a little bit more difficult because we need to convert each one of these over into a relative uncertainty before we can add them together. So, what that means is, if we diverge and digress just for a little bit, the absolute uncertainty in the mass, if I want to convert that to a percentage uncertainty, I would divide the absolute uncertainty in the mass divided by the mass times by 100. That would give me the percentage uncertainty. However, I don't want to do the percentage uncertainty, I want to calculate the relative uncertainty. And to do the relative uncertainty, I just don't multiply it by 100. So I've got the absolute uncertainty of the mass divided by the mass that I measured. So we could write this as the relative uncertainty is equal to the absolute uncertainty divided by the measurement. And in above here, the absolute uncertainty is this one here. So it would be equal to 0.01 divided by the measurement that we took. So let's say the measurement in this case here is 13.78 divided by 13.78, which would equal 7.26. Let me write this down, is equal to 7.26 by 10 to the minus 4. And that would be my relative uncertainty. Okay, so now that we know a little bit more about relative uncertainties, let's go back up here again and let's work out the absolute uncertainty of the potential energy. So we need to firstly, I like to go and get my formula and rewrite it in absolute uncertainty terms. EP, the absolute uncertainty of the EP, divided by the measurement, the potential energy measurement, is equal to the absolute uncertainty of the mass divided by the mass plus the absolute uncertainty of the gravity divided by the gravity plus the absolute uncertainty of the height divided by the height. Now I'm going to make an assumption in here that that's zero, because gravity doesn't vary and fluctuate much around the surface of the Earth, and so we'll leave that one out as zero. So, absolute uncertainty of the potential energy is now equal to the potential energy that we measured. Whoops. And if we look up here, the potential energy that we measured, let's use this one here, 0.210. So we're going to say 0.210. Whoops. Sorry, the absolute uncertainty is what we're trying to calculate. So we'll rewrite this then as, let me change, because now we've got a formula, let's change color. The absolute uncertainty in the potential energy divided by my measurement, 0.210, is equal to the absolute uncertainty in the mass, which we measured as, or estimated to be, 0.01 divided by the measurement, which was 13.78 grams. That was this here, the mass of the ball that we measured, plus, we're ignoring gravity, absolute uncertainty in the height, and we said that the height here, we worked out an absolute uncertainty of 0.03 divided by the height, which was 1.55. And note, as long as the mass, this mass here is in grams, and the uncertainty is in grams. This here, the absolute uncertainty is in meters, this is in meters. This uncertainty is in meters, the measurement's in meters. As long as all those units are consistent, the relative uncertainties will work out okay. All right, so now let's go and work out the absolute uncertainty in the potential energy. Absolute uncertainty in the potential energy is equal to 0.01 divided by 13.78, which is equal to 7.2568, 7.2568 plus 0.03 divided by 1.55, 0.03 divided by 1.55, let me work that out on my calculator, which is equal to 0.1935. Now if I add those two answers together, which is, let me pause it for a second and catch up, which is my pen, which is equal to, if I add those two together, that by the way is 7.6 by 10 to the minus 4, that should be by 10 to the minus 4, plus 0.1935 is equal to 0.02, that'll lose 008, and that is 210. So what we have in effect got at the moment is that we have the change in the absolute potential, absolute uncertainty in the potential energy divided by 0.210. So that's actually as a relative uncertainty is equal to that number plus that number. So the absolute uncertainty in the potential energy divided by 0.210 is equal to, what did we say before? 0.00208. Now I want to get rid of this down here because I want to end up with just the absolute uncertainty in the potential energy. That's what I want to end up with. The problem at the moment is I've actually got it as a relative uncertainty. So I need to multiply this side by 0.210 to cancel that out, which means I multiply that by 0.210, which gives me a result of the total potential, the absolute uncertainty in the potential energy is equal to 4.2169 by 10 to the minus 3, or 0.004 is my absolute uncertainty in the potential energy. And I can go back up in here as well, 0.004, and put it up into here, where it'll be plus or minus 0.004. 0.004. And then I can do the same thing for the kinetic and the velocity. And then I can do it for the time, and then I can do it for the range. So I can calculate all these uncertainties. And so just remember, we go down here, as a rule, just remember that when you want to calculate the absolute uncertainty in something, if it's multiplied, so if it's something like MGH, where you have little multipliers in here, not just additions, then you need to convert everything over to potentials, to relatives. So you convert everything over to a relative, add them all together, and then multiply by that initial value again, and that will give the absolute uncertainty in whatever you are looking for. Also remember, so if you are multiplying values together, then add the uncertainties. If you are subtracting, then add uncertainties. If you're dividing, then, you guessed it, add the uncertainties. Always add the uncertainties.